Hi, thank you for joining our conversation on virtual desktop infrastructure today. I will introduce you to the technology as it offers a compelling solution to modern needs. So why am I sharing this talk today? Well, my name is Liam Quinn, and I'm a marketing specialist with GIGABYTE in the Network and Communication Business Unit based out of Taipei, Taiwan. And as the global pandemic hit early this year, I realized how unprepared companies were for the idea of having employees work from home. Even here at GIGABYTE, we were unsure how to change our company culture to do so while maintaining productivity and keeping employees safe. With virtual desktop infrastructure, or VDI, companies can create desktop-like experiences from anywhere, and that is what we will discuss today. All right, with that out of the way, let's take a look at the agenda for this talk today. To give you a better understanding of the VDI environment, it is important to know what changes are happening that are enabling VDI. So, we'll compare traditional IT to the cloud, and then get into what VDI is. Then we'll look at forces that are driving the adoption of VDI, and I will talk about why companies should use it, but also what challenges there are. Then we'll take a look at some specific cases of how VDI can improve your business, such as who benefits the most, how it can save time or money. And next, we'll look at NVIDIA GPUs and GIGABYTE servers. And I'll leave you with a video showcasing some of our servers. So, what is different about today's work done by PC versus 10 or 20 years ago? Well, obviously we must adapt to change and how we want to do things. I mean, nowadays, we use our phones and computers at home to do work as well. So we now live in a any-device world where we use tablets, phones, personal laptops, and company laptops. Also, we have any application, meaning we use cloud applications, traditional applications, and even software as a service. We also have to cope with any platform. Some of us prefer Linux or Windows. Last, anywhere, as we need to be able to do work from any place. As you can imagine, there are many different combinations of how work is done, and IT needs to be able to manage all these instances, to protect data, as well as to keep productivity going. So now we have a lot of choices, which can be good or bad, but we have to adapt our system to it, and I mean from an IT perspective. So let's look at IT services. On the left, we are looking at the traditional model for IT services. Traditional IT follows a vertical system. Applications are tied to servers, which are tied to IP addresses, which are tied to switches and routers. As well, applications are on separate servers, one for email, one for data, one as a web server. And these resources within them are usually underutilized and inefficient. And application deployment happens on-site, with hardware and software done as well. So, how about putting all applications onto one server to improve utilization? Well, it sounds good, but if one goes down, they all go down. This is where VDI, or server virtualization, comes in. In the cloud model, applications are not bound to a server or IP addresses. The infrastructure for the cloud is based on virtualization, and often the server is not managed by your company. Okay, looking at the cloud architecture. The cloud has a dynamic structure in that it is great for scalable applications. You can easily acquire more resources or reduce them on demand. So what's unique about the cloud? Applications can be accessed via the cloud. Think Microsoft 365, which allows you to use productivity tools over the internet. Besides applications, the cloud also can deliver data or computing resources as a service. At this point, it is important to talk about how the cloud differentiates from virtualization, which is the main focus of our talk today. The cloud is more so about the delivery of resources, such as software or data. And virtualization is the process of creating virtual versions of infrastructure that can be used for the cloud. We will focus on virtualization going forward, and I'll offer a better explanation of it. The issue we have been discussing is how to create a great user experience, but do so in the current climate. Often people are content with their device's performance. So to offer an alternative way, it has to be just as good. VDI is essentially making desktop machines, or virtual machines, out of one powerful machine, the server. Just like any tablet or laptop you use, VDI also has an instance of an operating system. But this system is not on the device in front of you and not tied to the server hardware. Actually, it's in the virtual machine, but we will talk more on that soon. So, like the OS, the storage, or the hard drive, the SSD that you think of, the place where you store your important work files is not on your device. No, it is safely back in the data center. So, VDI is essentially splitting up all the server hardware into virtual machines. Each of these VMs could have the same amount of hardware available, or the hardware could be more efficiently used. Maybe a coworker, Chris, needs 32 gigabytes of RAM and a 16-core CPU, whereas I need 8 gigabytes of RAM and a 4-core CPU is enough. VDI technology allows for the server to partition the CPU cores and RAM to the instance, the user, that needs it. So VDI is making virtual machines by dividing a server's hardware, a single server, into portions of itself. Virtualization is what drives cloud technology. As you use Google Drive, you are accessing physical hardware that has been partitioned for you. I haven't mentioned GPU yet, but it will be a focus of this discussion today. And recently, technology improvements have made it possible. The GPU can share its resources across several virtual machines with virtual GPU. This is shared virtual GPU. Or it can pool the GPU resources to be used by a single virtual machine, called pass-through GPU. It has flexibility. So what is it about our new environment and needs that are pushing companies to use VDI? First off, the need for centralized management. We live in a distributed world with any app, any device, and so forth. But that doesn't mean IT needs to suffer. Rather, this is pushing for IT to consolidate and be more lean. And a server can alleviate some of the processing needed, so CPU or GPU processing can be offloaded to the server. Next, the server is where updates of hardware occur. In the past, chasing after aging devices took a lot of manpower and time to update or to fix them. With a centralized server for the hardware updates, it can be done from one location for multiple users. Second, we have shifted some of our workforce to remote work. Estimates in the US believe around 50% of work could be done from home, but changing the culture for that is tough. People like flexibility in when or where they work, as they can spend less time commuting and more time on their interests. People desire to improve their work-life balance, and the global situation is obviously promoting remote work too. Last, technology advancements. The speed, reliability, and coverage of internet at homes and on the road has improved such that it is easy to quickly access servers. The third force is cloud solutions. We have seen the evolution of virtualization from data centers to computing, VDI with CPUs, and now the inclusion of GPU for high parallel processing and other graphic-related work. Companies have noticed. NVIDIA and AMD are offering greater support for virtual GPU and VDI. So, VDI is an evolutionary trajectory. Last, security. Mitigating risk of losing sensitive data from lost or stolen devices can be done with secure data servers. Rather than store files on a device that can be lost or stolen, it can be stored in the data center. And last, networking speed has improved as mentioned earlier, as large files can safely be sent and accessed quickly. So, what does the VDI architecture look like? To explain, we will look at virtualization without virtual GPU, or VGPU, and then we will see one with virtual GPU. But first, a quick comment on GPU and CPU. GPU excels at handling graphics accelerated work and can handle a great number of compute-intensive instructions simultaneously. On the other hand, the fewer core CPU is for sequential serial processing, which is simpler mathematical calculations. So, often for more complex applications, a GPU is a huge boost. Okay, so For VDI, a server is built with typical hardware, CPU, RAM, network connections, and so forth, but also hardware that a desktop would have. I mean, if a server was designated as a data server, then a high core count CPU might be chosen over a higher clocked CPU. But in VDI, you need to account for the user, and they may need the higher clock speed. It depends. So you can't just use the data center CPU for VDI, and this is true for the other components. We aren't just repurposing the server, we need to reevaluate the components inside. So, getting back to the architecture. Once the hardware is chosen and installed, then a hypervisor is added. The popular choices nowadays are Microsoft Hyper-V, Citrix XenServer, VMware vSphere, and Red Hat Enterprise Virtualization. The hypervisor will create a virtualization layer between the server hardware and the virtual machines it creates, which are on another level. And each VM has its own instance of an operating system and apps. So the OS isn't tied to the server hardware. It is instead in the virtual machine. This is extremely useful because it allows for one virtual machine to use Windows 10 and another virtual machine to run Linux, or whichever OS one chooses. Now we add a GPU to the server. Then NVIDIA Virtual GPU software is installed in the hypervisor. Remember, we don't want the NVIDIA drivers attached to the physical hardware. Instead, we will have NVIDIA drivers with binaries and libraries in each virtual machine. Thus, in VDI, you create virtual machines that have virtual GPU, CPU, RAM, and more. And they exist unknowing of each other. They act as if they are their own machine, as the operating system and complete set of apps and drivers are moved to the virtual machine. And the virtual machines are accessed over a network. Stepping over to some of the benefits of VDI. The benefits that we will look at on the next slide are user experience, productivity and flexibility, cost benefits, ease of management and security, and finally, resource efficiency. Afterward, we will look at some of the challenges faced with VDI. So let's look at each benefit in greater detail. Okay, so the user experience is listed first, as a happy user is critical to the adoption of VDI. Users must have a great experience or they won't use it. And these users also want quick fixes and little to no downtime when repairing or upgrading is needed. Productivity and flexibility. Users can be wherever they want and continue work. They also have the freedom of operating systems to choose from. And third, data is stored in the data center, where it can be pooled, shared, and accessed by other users. The third advantage is financial. Centralized software management and leaner staff bring down the cost, while the dense server saves on floor space and rack space. Thus, total cost of ownership, or TCO, is reduced. And by using a thin client, power usage effectiveness, PUE, is improved. Next comes IT management and security. Centralized servers allow IT admins to monitor, patch, upgrade from one location, while minimizing risks of data leakage or compromising business-critical data from the centralized server. Add into this redundancy, a backup server ready to go should the other fail, and you have a stable environment with little to no downtime. And to round it out is resource efficiency. VMs access resources that are optimally determined. Just like we talked about before, comparing my workload to Chris's. Before virtualization, each CPU was dedicated to an application, such as an email server or data server. But with VDI, a single CPU server can run both functions, and do so with greater utilization. All in all, we have happy users, IT admins, and corporate likes the financial savings. Okay, let's move on to the challenges of VDI. First off, with any new technology, there will be challenges. Healthcare adopted it because they need access to medical records from different devices and locations. They really saw the value, but it can be a challenge for industries to adopt it. User adaptation. Adults aren't always the best at change, and couple that with the fact that there are a lot of applications that can't be virtualized, and you get headaches and a model that could fall apart. So the user's willingness or ability to adapt to VDI is the first challenge. Costs. All the hardware, installation, and testing must be done up front. All the planning and time occurs before devices are ready for users. This contrasts to purchasing one PC at a time, which can spread out the cost. Network connections. If network connections are slow or unreliable, it will greatly hurt the user experience. They won't be able to access the files they need and use the applications they want. They may stop using it as a result. So, reliable and fast networking is important. And last, IT proficiency. VDI may require current IT staff to get training in order to understand the complexity of VDI and how to implement it. Some IT admins may be unwilling to change to VDI because of the learning curve. As well, for the shift to VDI to happen, IT has to support the plan and do their best to make it work. So those are some of the challenges in VDI. Now that we are familiar with VDI, as well as the benefits and challenges that come with it, we'll look at how VDI is used in one particular industry, the oil and gas industry. And this will make sense to lead into the discussion of why virtual GPU can be advantageous. Then I'll follow up with examples of how VDI saves time and money. And we'll look at the types of users and categories for VDI. As for industries that have been leading the way in adopting VDI, we have healthcare, finance, government, engineering, and more. The oil and gas industry often use HPC, high-performance computing, to assist with exploration of sites. And for this, a large number of complex 2D and 3D images and other data is gathered in the survey process. They choose to use HPC systems because they can handle complex computations quickly. And these systems are GPU dense and run applications such as Schlumberger Petrol. By using VDI, they can manage large amounts of data while doing so from various locations. Next, we'll look at how GPUs are utilized in traditional desktops. Here, we are looking at 4 systems that need a discrete GPU in each desktop system. And each system utilizes their GPU at varying levels. The top user utilizes a GPU a lot, whereas the second one, not as much, but still requires one. With VDI, instead of having 4 systems that use 4 discrete GPUs, what if you could pool the resources into one system with only 2 or 3 GPUs that are shared by all 4 users? This is shared virtual GPU. This avoids hardware resources being wasted and can save money, as the virtual GPU resources, cores, memory, assigned to each can be based on how much is needed. As well, since the hardware used are in one central server, IT management can update the GPUs or drivers with greater ease. So this could save money and power used, and IT management can benefit from the consolidation. Moving forward, let's take a look at time savings with VDI. At one time or another, we're all going to deal with a PC that fails. Here we look at what happens when a PC does fail, compared to when there are problems with a virtual machine. When a desktop goes down, IT will have to initialize a backup device and go through the setup process. Also, recovering personal data can be challenging and data may be lost. If the PC is able to get the data, it can then be transferred back to the computer. Overall, the process can take up to a day. In contrast, for VDI, since all the data is backed up, you don't have to worry about trying to save your data. Simply initializing another device allows you to log back in, if, for whatever reason, there was an issue with the thin client. And this process only takes a couple minutes. So the ability to get back up and running is improved with VDI. Let's shift gears and see what energy savings are like. This table compares a 400-watt traditional desktop PC to a 48-watt thin client. A thin client is a computer that uses resources stored on a central server from computing to storage and connects remotely for all its work. Think of a small device between your monitor and the server as resources are sent via the network. Okay, so we're going to compare the cost of power for 2 users that use the devices for 8 hours per workday and 261 days per year. Why? I'm trying to compare a typical user that works around 50 weeks a year at 40 hours a week. By multiplying power consumption, 400 watts, by 8 hours, by 13 cents kilowatt hour, you get a daily energy cost of 42 cents. So the traditional PC uses 42 cents times 261 days, about $110 per year. And the thin client, 13 per year. Now, if we had 100 of each instant, that works out to nearly 11,000 in electricity versus just over 1,000 for the thin client. That saves nearly 10,000 per year. So you may ask, what about the server electricity cost? Well, two things. The server will run with greater efficiency because of its scale. Second, the thin clients may be a service as a solution, meaning the server energy costs are off-site and taken care of by the service provider. Instead, companies will pay for this service on demand as it is used. No matter how you look at it, it is using less power. And these thin clients have the extra value in that they can be used anytime and anywhere. So, with time and cost discussed, let's take a look at what kind of users use VDI. As I mentioned before, the type of virtual machine created is based on the user. You don't just give a random desktop or a laptop to use. The thin client or device will use resources that are customized for the user. On the left, a task worker that uses Outlook and Word doesn't need a system with a NVIDIA T4 or even a CPU with more than 4 cores. Customized to the user. So, let's look at a range of users. Going from left to right, the level of computation complexity increases, as does graphics acceleration usage, and the number of virtual machines typically decreases from left to right. So the users. Above each user, there are some applications they may use. Task workers handle basic tasks and don't need graphics acceleration. But the knowledge worker could use entry-level graphics for a more smooth experience as they use graphics accelerated work. By the time you reach a power user, graphics acceleration is a must. For Adobe products, desktops are usually fitted with NVIDIA Quadro GPUs for these users. And for designers, engineers, and AI scientists, they really want high-end GPUs and computing. Next, we're going to look at the spectrum of users, but in relation to virtualization technology. On the prior slide, I showed essentially the whole range of different types of users of VDI. Now, this slide breaks it down to focus more on graphics acceleration. On the left, the y-axis, you can see how image quality, costs, 2D and 3D work increases along the axis. Whereas on the x-axis, you have light users to heavy users. On the bottom left, task workers. They don't need hardware-based 3D acceleration. Software-based is fine, as the software 3D rendering is done by the CPU. Remember, they use Excel or Outlook, nothing intense. So, if these users wanted virtualization, they could choose soft 3D. Next, the knowledge workers. They may use web browsers or view videos and prefer higher resolution screens, which need GPU acceleration. For virtualization, they could choose VSGA technology, or Virtual Shared Graphics Acceleration, which is used by VMware, and it can make virtual machines from one or many GPUs. Then the power users, designers, and engineers who really require a powerful GPU or several GPUs to do their work. And in some instances, they use VDGA, Virtual Dedicated Graphics Acceleration, where instead of sharing a virtual GPU across multiple virtual machines, they may prefer all the vGPU resources devoted to one user. But notice, in the background, covering the whole range of users, is NVIDIA Virtual GPU software. There are 4 products NVIDIA sells, and they cover the full range of users. As of now, these NVIDIA solutions outperform soft 3D, VSGA, and VDGA technologies. And NVIDIA solutions are excellent choices because NVIDIA makes the solutions specifically for their products and is as up-to-date as possible. So, what GPUs are used in virtualization? We've talked about types of users, and we need to get more specific as to what GPUs are being used for VDI. For the sake of simplification and focusing on the most current GPUs, I've only chosen these 4 from NVIDIA. There is a lot of information for you to compare, but I will take a quick walk through them. GIGABYTE has servers ready for ultra high-end work using A100, as well as entry-level performance like the T4 or RTX 6000. The Ampere architecture, using the A100, has the newest technology by NVIDIA, and is the first accelerator by NVIDIA to include PCIe Gen 4, and is used in 3D design and AI, just to name a few. Then comes the 2 Quadro RTX models, which are more graphics-oriented, and they differ in that the RTX 8000 has 2 times the amount of GPU memory as the RTX 6000. And last, we have the small single-slot Turing T4. It is extremely versatile because of its size, and it is easy to fit many of them in a small case with low power consumption. Yet, it can still handle 3D design and AI work. Now, we will move on to GIGABYTE servers that use these GPUs. Here we are looking at a list of GIGABYTE servers that have been NVIDIA Virtual GPU certified. Currently, there are 19 models of our servers that are certified on NVIDIA's site, and more are coming. As you may notice, the new A100 is missing. Once NVIDIA posts the new certified servers, you will see that GIGABYTE has been supporting the A100. As well, NVIDIA will be updating their official list to include the new Ampere A100. NVIDIA is also launching the new NVIDIA Qualified Servers program, so there will be greater support and resources for people that choose NVIDIA A100 servers. So, what about other GPUs by NVIDIA? Some of you may be familiar with the NVIDIA B100. Why is it missing from the above list? While we do have servers that are certified for the V100 and other models, those products are being phased out for newer models. Finally, we've reached the conclusion for my talk today. I hope you have a better understanding of virtual desktop infrastructure, or virtual servers, and who uses servers with virtual GPU. Essentially, we've reached the point where a server can create virtual machines that can help compute heavy workloads that data scientists do, and help in oil and gas exploration. Yet still target users that need application-based software. And virtual machines can be accessed from anywhere, so as long as you have a network connection. So, remember, VDI is a reaction to needs. If traditional servers were the best option, there wouldn't be a shift to the cloud. As well, the market for desktop virtualization has a compound annual growth rate of 11%, whereas hyper-converged systems, which are often used in virtualization, have a compound annual growth rate of 33%. Clearly, industries are adopting VDI and servers built for virtualization, and that growth shows. GIGABYTE is committed to providing the best servers that are certified by NVIDIA to use for virtual desktop infrastructure. And I will leave you with some examples of our servers today. Thank you.